My RainBird irrigation controller is working terrible for many years now. It takes literally minutes before I can start a group. And today we fix those issues by creating an incredible responsive irrigation controller by ourselves. It's a build that you can do by yourself for around 50 euros. This video is a bit an experiment for me. Normally my builds have the assumption that you have some understanding about electronics and automation. But as I can imagine that many people are fed up with their slow responding irrigation system, I try to make this video understandable for like everyone. So also if you don't have any experience with electronics or automation, this is the moment to start with it. No, let's not go that far. I just want to teach you how you can create your incredibly fast responding irrigation controller by yourself, by only teaching you the skills that are necessary for this project. I'll guide you through step by step. If you don't have any experience with electronics or automation, I hope you find this workable as well. And if you miss things, let me know, post it in the comments and I'll try to help you there. Check the chapters on the timeline if you're interested in a specific topic, or simply if you want to watch some part again. Let's start by showing you my problem case. This is the irrigation system for the garden. It's making use of a RainBird controller. Let's see what happens if we water one group. It should take a few seconds, right? And there it is, let's water our group. So apparently that's not how it should work. And I have no clue if I'm the only one with this problem. And this whole system can work automatic indeed. It starts and stops groups on specific times. Even based on the weather if you want. But in my experience, I also like to just start a group when I'm drinking a cup of coffee in the garden and just watch the sprinklers. Maybe I'm the only one, but I like it. I also use this water pump for other parts of the property. I have water taps there around the pond, around the wellness area, to just water some plants there. And for those cases, it's very convenient if it's responsive. Apparently that's not possible with my RainBird controller. I tried to set it up many times from scratch. I tried things with the Wi-Fi, I have no clue, but the responsiveness stays terrible. So I thought about some options here, and it's not a complex system, it are just solenoid valves. 24 volt AC, so how complicated can it be? I'll take a switchboard with one relay for every group, I'll attach an ESP to it, some buttons in Home Assistant, and if I want I can do all the automation there. In my experience those relay boards with an ESP are like incredibly responsive. So I hope that will solve my problem completely. I want to make this project as flexible and adaptable as possible for your specific setup. For my RainBird controller and my RainBird solenoid valves, I measured the voltage to make sure that I order the correct power supply for my setup. So I'm measuring here the voltage when I start one group on the current RainBird controller, and I see that it gives me 24 volt AC. So make sure you order an AC power supply. The majority of the power supplies that you find are DC. Search for a correct power supply for yourself. In the components used section, I'll show the exact power supply that I bought. So for your setup it can be different, but I expect that there is not that much variety in it, but I can be wrong there. So make sure that you always order the correct voltage and that it has enough power for your setup. Something important to keep in mind here. You don't need to have a power supply that is able to open all the solenoid valves at the same time, because in most cases you only use one or a few of those valves at the same time, because the water pump is not able to provide enough water or pressure to provide all the groups from water at the same time. So keep this in mind when selecting the correct power supply for your specific installation. And I like to work in a structured way to detect issues in an as early stage as possible. So here I'm connecting the 24 volt AC power supply that I ordered directly on one of the valves. If the valve opens, my concept is working and I can make use of this power supply and my switchboard to do the rest of the build. For me this is the first confirmation that my concept will work. Quick overview of the components that I used for this build. I'm using an ESP-RZXe instead of an ESP-8266 that I'm often using. I made this decision based on the capacity of the ESP-RZXe. It has more GPIO pins that I can use. Not only for this project, but also maybe for future projects. So that I can use that same ESP that is running for my water pump to connect sensors to, like temperature sensors or water flow sensors or other things that I will make in the future. And as the costs are not that a big difference, I directly went for the ESP-32. For my installation I used an 8-channel switchboard. And although I have 6 groups at this moment, I'm able to expand with this in the future without doing modifications later. The power supply that I'm using here is a 30 VA power supply and it provides 24 volt AC alternating current. And better safe than sorry, I'll repeat it here. Make sure that you order the right power supply, otherwise it will not work for your installation. Then there are some components that I designed to make a 3D print of, like the box to put everything in and some spacers to keep everything nice and tight on its own space in the box. I will make the 3D printable files available on my website, so that you can easily download them and print them by yourself for this setup. If you don't have a 3D printer, ask around or make use of some standard boxes that you can buy from a hardware store, for example. It doesn't have to be in those specific measures. I'm also thinking about offering this as a complete package from my website. So the components, the custom-made box and some already configured ESP device, so that you simply can connect it to your own home assistant. If there is interest for that, let me know. I can investigate the possibilities for that. If you have questions in the meantime, post them in the comments and I'll try to help you. And if you like projects like this, then please like the video and subscribe to the channel. As a beginning content creator, it's very important for me and I want to broaden my audience to inspire more people with projects like this, and there are so much more to come. So keep an eye on the other videos as well. At this moment there are just a few online, but I have so much more on my to-do list that I want to create guidance videos about. And I'm very interested in what you want to see. So join me in this journey. But first, let's continue with this project and create an incredibly fast irrigation controller. I'll give you a quick overview of how the switchboard and the ESP breakout board is wired. So the positive is coming in. One of the positives goes to the breakout board's positive to power the ESP-32. One of the positive wires goes to the switchboard, to the VCC. The ground wire from the power supply goes to the ground of the switchboard. And we have one ground that goes to the breakout board's ground of the ESP-32. And now I hear you asking, there is also a ground in the line of pins next to the GPIO and the VCC. It's this ground. And that ground I connected to another ground pin of the ESP-32. I'm not that an expert of those boards, so if that is really necessary, I don't know. As long as the grounds are connected, it should work. But because this pin was there, I just connected it to the ground of the ESP board. The relay control pins are connected to the ESP GPIOs as I give in the overview. If you connect it in that way, it should work for an 8-channel relay switchboard like this. So if you want to reproduce this, or if you have an irrigation system that is giving you the same frustrations as mine, and you're not into those electronics at all, you can simply rebuild what I'm creating now, and it should work fine for you. If you have questions there, let me know, drop it in the comments and I'll try to help you out. But it should all work if you follow these steps. It's quite a simple setup because it is a standard relay, a standard switchboard that I'm using. So the switchboard in a lot of projects is exactly the same. It's only the build around it that will change. I'm using those switchboards quite often for projects like the speaker selector, the automatic jacuzzi cover lift, but also for this build where we want to control some solenoid valves for the irrigation system. So just follow along and it will work out fine for you. I will publish the wiring diagram so you can do exactly the same. And make sure that you use the GPIO pins that are useful for this. Otherwise it can happen that the ESP is not booting or is not correctly booting, and that you have all kind of weird cases. While playing around with it, I had it as well. So I changed some of the GPIOs that I was using first, and now I'm using GPIOs that are working fully for this specific build. This is the 8-channel switchboard that I'm using. So we have the 8 switches and we will use those connectors per group. So we can make it like irrigation group 1, 2 till 8. The connectors that we use here are the middle ones and the bottom ones. And while this is not that complicated, I like to prevent mistakes. So also on this simple build, I'll place marks on the connectors that I will use. The pins on the switchboards go from like ground, the 8 connectors per relay that we connect to a GPIO on the ESP, and a VCC, and VCC is the power. Here we power the switchboard with the 5 voltage. Here I am doing some preparations on the wiring of the switchboard. And the wiring diagram is available in the comments or on my website. By looking at this part of the video and the wiring diagram, you should be able to do the correct wiring by yourself. If you are in doubt, contact me for any help. Because I promise that this video will also be useful if you don't have any experience with electronics or home automation, I need to add this step. It is how to add a new ESP device to your ESP Home in Home Assistant. We go to our ESP Home Builder and we choose New Device. Continue, and then we give the new device a name. I'll go for Irrigation Controller. Next, it's an ESP-32 that we are using. I will select Skip for now, because I want to modify the configuration first before I'll flash it to the ESP. Here we see the ESP that we just created. It's offline because we didn't install it yet. And now we'll update this device with the correct information. And if you're sharp, you see here that the name is Irrigation Controller. And in the rest of the video, Irrigation. It's because I added this step later. So just ignore that difference and call your ESP Irrigation. Of course you can choose for a different name, but as I promised to keep it as simple as possible so that you can follow this step by step, just go for Irrigation. I'm trying to make my videos a bit shorter. So I'll go quickly through this and I'll not explain all the standard parameters that are available in an ESP config. I only mention the things that are relevant or that I updated. I like to make use of a static IP address instead of a DHCP address. In this way I can do a quick check if the device is up. This section is relevant to control the switchboard that we will attach. We define the GPIO pins and we give it a name that later will be exposed in our Home Assistant so that we can recognize it easily. I added the parameter inverted is true. In this way, a light on the switchboard for that specific switch goes on if I'm starting that zone. So I'm using the GPIO 4 for zone 1, GPIO 16 for zone 2, etc. I will make this code available on the site or in the comments so that you can make use of this. If you use those GPIO pins, everything should work fine. Let's compile the code and flash it to the ESP. I like to do the manual download. It gives me way less issues than when I'm doing flashes via wireless. I'll choose the factory format and it asks me to save it. I already created this file before, so I'll save it as irrigation.bin. Yes, replace, and we keep it. Okay, I'm using PowerShell for this. Standard available in Windows. If you didn't use this before, it's possible that it gives you some errors, that there is no Python installed. If that's the case, install that first and then proceed. This is the command that I use to flash the device. For you it can be a bit different. Make sure you choose the correct port and of course update the file name. Interesting. Normally with an ESP-8266 this goes well. But for this ESP-32 we need to put it in boot mode first. Press and hold boot. Press reset and release and then release boot. Execute the command again and it should flash as you see on the screen now. We go to ESP Home in our Home Assistant. It is possible that in the overview it shows add the device. If it asks that, add it first. After adding, it will be visible in this list. For me it is visible in this list. And we will go to the device to test it. This is the ESP that I just gave the correct code and I flashed it again. So now we should be able to see the switches that it exposes to us. Let's go there, irrigation. And here we see zone 1 to zone 8. Now I'm going to press them and then let's see what happens on the switchboard. And that looks awesome. And I'm now also happy because this means that this is more responsive than the RainBird system that we have. So the foundation is good. And I can make this really pretty. with like a separate PCB with connectors on it and have terminals for every valve. But I'm going the easy way here. Like we have the 8 relais, and to make it as simple as possible, we just wire it according to the diagram. So one wire of the PSU goes to the middle terminal of every switch, and we simply use the other, like I indicated, the other terminal per switch for the other wire to the valve. In that way we keep the setup as simple as possible, and it should all work fine. If everything is working as it should, of course we put it in a nice box so that it is resistant against some dust and maybe even some water in the pump house. I created a small dashboard in Home Assistant for all the groups that I want to control. By adding buttons for the entities that the ESP board is exposing, you have direct control to all the zones that you want to irrigate, directly from the dashboard of your preference. I created a small dashboard here to show you how responsive it is now. If I start zone 1 for example, it directly results in turning on zone 1. And that's exactly what I would expect from a responsive irrigation system. And the other way around also, of course. This is the 3D printed box that I use to install all the components in. It makes it resistant against some dirt. Because I'm using a 230 to 5 volt transformer to power the ESP and the switchboard, I'll isolate this transformer in a small box, so that it is completely separated from the rest of the build. Because this is the 230 volt AC side, I think this is a safe move to do. So I'm using this small box for it, and I'll later show how we glue everything together. I created the box so that it is spacious enough to install all the components easily in. The switchboard will go on the bottom, and I created some spacers to flatten the surface on the top of the switchboard. In this way I can easily glue the small box with the transformer on it, and on the bigger spacer we can mount the breakout board with the ESP on it. Everything will be nice and tight in place in this way. This is how it looks like if the spacers are pressed on top of the switchboard. The box with the AC to DC transformer will be mounted on the small spacer, and the breakout board with the ESP on the bigger spacer. For those kind of projects I really like to use hot glue. It works very well with 3D printed parts. I'll simply put some glue in the bottom of the box and I'll press the transformer on it. Then hold it for a while till the glue cools down and it is sturdy. I always do a bit extra glue on the wires, or where the wires touch the box. And this way is more resistant to some friction on the wires later. Together with the box goes a small lid. To have the lid sturdy on the box, I'll also use a few drops of hot glue. To keep these spacers in its place, I'm also using some drops of hot glue. Don't make it more complicated than it is. Just add some drops of the hot glue on the switchboard, press the spacers on it, let it cool, and you're good. Next step is fixing the switchboard. Add some hot glue on the PCB and on the bottom of the box, and just press them together. Add a few drops of hot glue on the small spacer and press the small box on top of it. For the breakout board with the ESP the same. Add some hot glue on the big spacer and press the board on it. And here make sure that you leave enough space to use the connectors later. Because if they overlap, it will be a struggle. Prevent some hassle later. The components are now in place. Let's give the wire clamps a fixed place so that they easily can be used later if necessary. And be careful, those small ones are the ones that provide 5 volt for the ESP and the switchboard, and the bigger wire clamp that we will install later provides the 24 volt AC. The 5 volt clamps can be easily glued on the leftover space of the bigger spacer. And this is a moment where I wished that I had extended the wire of the AC power supply, because now it doesn't look like an issue, but I regret it later. So if you're starting with this mount, just extend the cable so that you can have the power supply further away from the controller. I'm using 2 different clamps for the power supply here. One wire to all the switches that we daisy chained together earlier. The other wire goes in this 5-way terminal block. Also here, I'll mount those terminal blocks with a few drops of glue on the side of the box, and make sure that the 5-way terminal block can be easily reached for the wiring that we need to do with the valves, and that the box can be easily closed. Also here I'm using some hot glue on the wires and the box to provide some strain relief for the electrical wires. Quick check if the box can still be closed. Now, that's possible, so I like to do some testing before I'll install it in my pump house. If there are some issues, you can better fix it inside than when it is already installed. The testing can be easily done by measuring the voltage. on the clamp of the side of the box with the wire of the power supply and the bottom terminal of every switch on the switchboard. If you turn on that group, it should give approximately the 24 voltage AC if it's on and nothing if it's off. And a quick tip for now, add some simple labels on the side of the box with the group number that corresponds with the group in Home Assistant. Although it's very simple to do corrections later in the code or in your automation, it's just handy if the number here is the same as in your Home Assistant. And although I have only 6 volts connected, it already became quite a big bundle of wires. It exactly fitted through the hole in the side of the box. Looking back on the project, this hole should be a bit bigger. So in the 3D design that I will put online, I will adjust that already, so that it is easier to install later. The irrigation system improvement is coming to an end, and I'm really happy with how responsive it is now. But there are a few things that I wished I had done better before. Let's describe a few lessons learned, so that if you're going to do this project, you can do that at the start. It would be more convenient if the wire from the 24 volt AC power adapter was longer. So I wish I had extended that in the beginning. Then it was easier to mount it to the back plate of the pump house. And it will work out, but it's a little bit more a struggle. And in the beginning of this project I overlooked how to mount the box with the components to the back plate of the pump house. Now I created this bracket. I can mount it with like 6 screws to the back plate, and I can simply press the box with the components in it. The sun is shining, let's go out. I will do the final installation and then we wrap up this project. Let's see if we can do a nice installation of the components to the back plate. Yes, a longer wire between the power supply and the ESP board would be convenient. Although I had some struggles with the short wires, it all worked out well, and I'm really happy with this end result. That summarizes this build. Let's see how responsive it is when we really want to use the irrigation groups. To do some real-world testing, I'll turn on the sprinklers that are visible now. So that's the responsiveness that I was expecting from it. For me this project worked out awesome. Like after years of frustration with the RainBird system, and I really tried to get that working smooth, but it simply didn't work out. This was my last resort to try, by building something myself. And as it does exactly what I want, I'm really happy with the end result. It took me some time, but also for this project I have a really dynamic system now that I completely understand and that I can integrate with my Home Assistant. I can create automations that are necessary, and this responsiveness is very important for future projects that I have in mind, where I want to use groundwater and that I need to fill a buffer, for example. To summarize, I really like this. In previous projects I went through the component costs in detail. For this project I'll keep it simple. I'll give an overview on the side here, and for less than 50 euros I think this is working awesome. Okay, the RainBird doesn't have a subscription either, so that's a cool thing of RainBird. But I was really frustrated by the responsiveness, which made it unworkable for me. If you have an irrigation system with like monthly subscription costs, this is even more interesting for you. Because with this build you have everything in your own control, integrated in Home Assistant. And if you're able to contact your Home Assistant from outside your house via VPN or something, you also don't have any restrictions there. I will spend a bit more time on further automating this. Like schemes to water specific groups on specific times, maybe on temperature, maybe on lux based on the sun, or on presence. Because you don't want that the irrigation starts if somebody is moving around in the garden. Or maybe you want. All those things are possible with an open system like this. If you have questions about this build, then post them in the comments and I'll try to answer you. If you're creating this build yourself, I'm very interested in your findings and experiences. Do you see any improvement somewhere? Then also let me know. I'm really curious about that. If you like those kind of projects, then of course like the video and help me and broaden my audience. As a beginning content creator, I'm trying to find my way around what works and what you like to see. Then also take a look at my other projects. There are a few online now, but there are a lot more to come. I have a lot of things in mind that I want to create guidance videos about and inspire you or motivate you to do the same. And as for now, thank you for watching. I'm John, this was Forest Guy Builds, and I hope to see you in one of my next projects.